So thank you, CXL Forum, and thanks MemVerge for hosting this event. So glad to be here. So today's topic, we're going to talk about the CXL switch and how this CXL switch can enable better computing and also that apply to the AI machine learning. There's a lot of usage case today, right? So my name is Jiang, and I'm come from a startup called Xconn Technologies. So Xconn Technologies is a IC startup in the Silicon Valley. So the company was started 3 years ago in 2020. So we're about more than 3 year and a couple months old. So let me go to today's topic. So first of all, we are a chip company. So we build the CXL switch. The switch we build, we already have the IC. So this is the IC was sampled back last summer. So this is a CXL 2.0 switch. And this is also a PCIe Gen 5 switch as well, because everybody knows the CXL is built on top of the PCIe technology, leverage all the existing, the PCIe advanced feature and many years of IP development. So the switch we're having is have the largest lane count. So this switch has a total 256 lanes. And the total switching capacity is reaching to 2 terabytes per second. This switch is, at the beginning of the design, we kind of targeted the CXL as our main application, and also the data center, all these AI computing as our main market for this switch IC. So we didn't put any thought into the other usage case for our switch. We're just single mind focus on this data center computing area. That's why we be able to optimize a lot of the design. So for example, the CXL, everybody today here is talking about the memory usage case, right? So at least we see the memory expansion, pooling, sharing. That's probably the first wave of the application for this CXL. But CXL continue to evolve with many advanced features to try to fit into the modern computing. So later, of course, the CXL going to expand to many other usage cases. And but the first use case we see, and we agree with many experts here, is this through the memory pooling, through the CXL to do this memory application. And for the memory application, we also understand this latency requirement is very critical, because all the customer we talk to, all the other hyperscalers, they are super concerned about the latency they incurred through the CXL. So that's where we very much optimize our design to achieve the lowest port-to-port latency, basically through our switch. And all these memory application, our switch only add a very minimal latency into this memory path, memory process. Another thing is that the data center, they also require very low power consumption. That's where we also optimize our architecture to achieve the lowest power possible. And through our switch, because it has the largest lane count, largest port count for the data center usage, we'll be able to reduce the PCB size, reduce the TCO overall for the end user as well. So today we have our silicon, not only the first silicon A0, we already have our A1 silicon in our lab. So the chip we already have work today with the processors, Intel and AMD processors, which are the CXL 1.1 at this point. Of course, these are two companies. They didn't stop here. They continue to develop the next generation processor. And also we work with a number of CXL memory controller, memory device, make sure the inter-op issues are resolved. So we're moving along quite well with the processor, memory device, and our switch kind of forming a kind of ecosystem, be able to provide a solution through the processor, through our switch, and be able to access the memory device. Then we're working with the upcoming CXL 2.0 processors to make sure we getting to work with them next year when those processors are getting available into the market. And also people are mentioning, the lot of computing devices, they are still, majority of them are PCIe based. So we do see the coexistence between PCIe and the CXL going to be for a very long time. So our switch are actually, the nice thing about it is it'll work with a hybrid mode, basically mix the CXL and the PCIe. So for many years to come, our switch would be able to still bridge the two worlds until everybody embrace the CXL world, right? But I imagine that take some time to get in there. So as we are a chip company, we already have the samples, and those chip samples are available as right now. And the first generation switch chip going to go to production first half next year. So that's kind of in general our plan. So this is first time I'm here in the Europe, so want to introduce this switch chip to everybody to make you be aware, we are, the CXL world is chugging along, and we are building our switch, and so this ecosystem almost formed with processor, switch, and the device, and many other devices that come in very nicely. So let me move on to some very simple usage cases to introduce this usage of our switch. So first of all, we talk about the memory expansion and some usage cases that Shriji also talk about the in-memory database, right? So in-memory database, we think, the in-memory database, a lot of times they require a huge amount of memory to be attached. So some of them require, 10, 20, or even 30 terabyte, or even bigger kind of memory footprint. And in the past, it'll be very hard to get into that kind of large size of memory size, because for a CPU socket, you only have that limited number of DIMM channels available. And expand beyond that is possible, but it can be very complicated and costly. And through this CXL switch, we can kind of expand that channel, right? You can imagine that how many switch port you have is how many DIMM channel you added to that. So our switch more looks like an amplifier, through one of the channel, you amplified it to many multiples of channels. So our chip is going to provide a total 32 ports. So if you all use up these 32 ports, you expand 32 DIMM channels that immediately add a lot of memory. So very simple case that our switch would be enable this memory expansion tremendously to a very large scale. So I won't explain further, the expansion, but it's very simple to understand. So next, want to talk about this memory pooling, which is we see the most popular usage for this CXL memory application. So memory pooling not only work today. So on the left side of the picture, that's today's picture. All these hosts, they are supporting CXL 1.1, and the devices, the memory device, are single logical device as of today. However, in the future or next year, we do see these hosts going to the 2.0, and the memory device going to support a multiple logical device, MLD. And our switch work in both cases. In the today case, our switch kind of virtualize all the memory pool that behind it to form, to manage through a fabric manager to be able to manage these big memory pool formed by SLD devices. But in the future, our switch also comply to the CXL 2.0 spec and be able to work immediately with the MLD and the CXL 2.0 processors. So also some concept borrowed from CXL 3.0. In the 3.0, they are enabling this switch cascading or inter-switch connectivity. And our switch today can also support this cascading. So in certain cases, our customer, they want to build a very large size memory pool. And just 32 ports of our single switch not enough. So in this case, we can do the cascading of a number of switches to enable them to form a very big memory pool. And of course, in the next generation, 3.0, we're going to support a fabric network, which enable an even large size memory pool. All right, so those are the applications. Let me move on to the hardware we're having. We had, so people can easily see the chip, the silicon, which is in the final package form. You can see on this picture, top is our silicon, and we also have this reference design hardware in a kind of chassis, in a rack, in a chassis form, showed here. So in the middle, of course, is our switch, which has a small heatsink on top of it, and then we have many ports through, spanning out of this IC. So this is our reference design platform. We've been developing using this platform to do a lot of validation and also development. So let me show you the memory pooling, since today's topic we're centering around this memory application. So this is the picture or the architecture diagram that we're using in our own development. So again, in the center is our switch, and the top, the red colored, that's the CXL host, like those hosts offered by Intel and AMD. And for the memory pooling topology, because this memory pool is being shared by multiple hosts. So here we just use two hosts to represent this development platform. And in case that's our setup in our lab. Of course, once you have two hosts working, you can further expand it to 4 or 8 hosts. And on the downstream part, we have two memory expander device. Then we have a management host that implements the fabric manager function that works with our switch. So this total diagram or architecture kind of captured our development platform we're using to prove concept of this memory pooling, development of fabric manager, all these things to work together. Let me show you another picture, which is the hardware setup we're using in our lab. So I put some of the reference design hardware boards here. So from the CXL host, we have some retimer board that expand or kind of connected to our switch. In the middle is our switch, the reference design platform we just showed. And we also have built some PCIe or CAM slot expander or the EDSSF expander board to enable the downstream port to be populated with many more CXL memory devices. And on the management host, we use a small board from that's basically powered by ARM processor that we're doing all this management fabric manager software running on that board. Okay, so this kind of setup kind of allowed us to do all this memory pooling proof of concept. And we've been successfully bring up this system in our lab and be able to do the memory pooling. So next one actually is a demo video. So let me try to play the video, but only to certain. Okay, so you see if I can.
Here's the setup.
Play it. So let me show. Let me just talk about this demo kind of scenario. In the real demo is in the MemVerge booth. So we have a setup there. If anybody is interested to see the real demo video, you can go to the MemVerge booth to see the video. And also I'm going to provide a link on the YouTube to allow you to see that on the YouTube as well. So this picture diagram shows there's two hosts, host A and host B. And these two hosts has allocated HDM, which is going to use the CXL memory. These two segments of HDM through our switch actually map to a CXL device. So both these two hosts would be able to share this one single memory device. So we just use one memory device to show, through the switch, they can share this memory device. But of course, memory pooling, we are going to put a multiple of CXL memory device into this pool. For this demo purpose, we just use one single device. And these two segments from host A and host B, they actually map to the different location in this CXL memory module, all right? Let me see, so let me show.
And there's one for each of the hosts.
So this,
in the middle is the.
All right, so this is the real setup in our lab. As you can see, in the middle is our switchboard. We just have a picture in the previous slide. Okay? And on the left side is one of the Intel Sapphire Rapid server processor. And also right side is another one. And you can see the cable through the cable up connect to our switchboard. And on the switchboard, we have one single memory module that plug into the CAM slot. So this is the setup we use in our lab to show this demonstration. We go to the next. And we're running some test software using the, on this screen, on the left side, the upper left side represent the host A. The upper left side represent the host A, and the lower left side represent the host B. So both of these two hosts, they can discover and locate the CXL memory module. Then we run some application that basically write some data into the CXL module and read from that memory memory location. So from the host, one side, it writes this text file into this CXL memory, and then read it out and display it on the screen. And same thing on the host B or host 2 side. So this is a very simple kind of demonstration of memory pooling on the one device. And as Charles earlier mentioned, that there could be memory sharing through the software, through the usage of, let's say, MemVerge software. That's possible. We're working with MemVerge on the next step to demo this memory sharing as much as the higher performance of this CXL memory pooling and sharing to demonstrate the further usage case for this memory application. So because audio couldn't play out enough, so I'm not going to play this video here, but you are welcome to stop by the MemVerge booth to see the real video. Okay, let me move on to the next slide. So this is what's happening today. Of course, everybody is looking at the future, right? In the future, application of CXL 3.x, what kind of usage case going to get enabled? So the diagram is simply from the CXL consortium, and the CXL consortium, they're talking about what's a usage case to support during the CXL 3.0 or 3.1 stage. So what you get from this picture is you see this switch get cascaded. And they even have this concept of spine switch and also the leaf switch. So it means all this big cluster of computing network is further connected through this switch to form a very big network, a fabric network to do this computing. And also you see multiple of these devices like accelerator, CPUs, memories, NIC card, all connected through the CXL switch. And we believe this is the future for the computing, especially CXL provide cache coherency and a very high speed, a very efficient connectivity between all these heterogeneous computing units. So we kind of, this is going to be our next generation product going to offer to support all these features as well. And we do see this has a lot of traction and a lot of support in terms of supporting the AI and machine learning that everybody is kind of chasing these days. And we do see some new architecture or new emerging device that could form and to support this kind of application. So let me go to a little bit imagination of into the future, what we see going to be, right? So anybody familiar with this picture probably can recognize, this is a little bit similar to what's right now a lot of AI computing, the platform usage. There's a number of accelerators and the CPUs, memory device, storage device, NIC card, they connected. However, it's a little bit different, right? So I put the CXL switch in the behind this accelerator and also between those heterogeneous computing devices. So what we understand or what we see is the CXL switch can provide a lot of capability to support this AI computing. So this is just represent one single node of this computing. And on the top, we also put a link to the CXL spine switch. Basically, through this kind of interconnect, you can connect a larger cluster of computing, right? So the switch will provide the memory expansion, pooling, and sharing. So for this functionality we already talked about. But also the switch that behind these accelerators, they actually has a large enough bandwidth to support what they call the all-to-all connection. So all-to-all connection kind of enable all these accelerators to fully exchange the data between themselves. And through multiple or through the CXL 3.x switch, the PCIe bandwidth is large enough to support all this, and you can have multiple switches to support this activity. And in the CXL switch that connecting the heterogeneous computing units, we also see this switch can also support this all reduce or all gather kind of operation as well. Then people also talk about the CXL memory, and they talk about the in-memory computing. I think this make a lot of sense because all these all reduce or all gather computing, they're actually just doing all this in-memory compute. That would be a good fit. So our switch would be able to support all this. And the switch is also be able to support up to 496 nodes for the CXL 3.x devices. So that's kind of into the future, and this is the end of my presentation. I'm open to answer any questions if you have.